Welcome to qnawire.
To calculate the test statistic for a two-sample t-test when assuming equal variances, we first need to find the pooled standard deviation, which is going to be one less than the first sample size, which is 15 times the standard deviation squared. So that would be 3.7 squared, plus one less than the second sample size. So that would be 11 times its standard deviation, 4.6 squared, divided by 2 less than the sum of the two samples. So that'd be 16 plus 12, which is 28, minus 2 would be 26. This calculates to 4.105, and now to find the test statistic, that's going to be the difference between the two sample means minus the difference between the two hypothesized means, which is 0, over the pooled standard deviation times the square root of 1 over the sample sizes. So that's going to be 5.7 minus 7.4 over 4.105 times the square root of 1 over 16 plus 1 over 12. And we're doing this to two places. And that's negative 1.08. And now the p-value is to three places. If we go from a t-score of negative 1.08 with 26 degrees of freedom and a significance of 0.10, and the fact that this is two-tailed because it's not or equal to, the p-value is 0.290 to three places. And because that is greater than our alpha of 0.10, we would reject the null hypothesis. There is insufficient evidence that the means differ. So that would be choice B. Now part B, the confidence interval is the difference between the two sample means plus or minus the critical t times the pooled standard deviation times the square root of 1 over the sample sizes. I actually think with the sample sizes, no, we should probably use the critical t of small sample size. We don't know the population standard deviation, so the critical t with 26 degrees of freedom with a significance of 0.1 is 1.7056. The pooled standard deviation again is 4.105. The difference of the means was 5.7 and 7.4. So our lower boundary to two places is negative 4.37. And our upper boundary is positive 0.97. With 90% confidence, the difference in the means of the two populations is estimated to fall inside this interval. There is insufficient evidence because 0 is within this interval.